Observations of an observer. I'm telling you folks, there's something out there. I don't know what, but well, I think by the time you get finished watching this video, you might agree with me. So this video is about ACE, the Advanced Composition Explorer Satellite. This satellite has helped our understanding so much. What we have learned in the last decade, and in this case with this satellite, nearly 2 decades now, and its mission is going to be extended until 2040, has been tremendous. It literally opened our eyes to so much about our sun, our earth, and our connection to the solar system and beyond. ACE observes particles of solar, interplanetary, interstellar, and galactic origins, spanning the energy range from solar wind ions to galactic cosmic ray nuclei to better understand the formation and evolution of the solar system. ACE also provides near real-time solar wind information over short periods of time for space weather forecasting. It was launched in August of 1997, and the operating network is by the Deep Space Network. The goals for ACE. The primary objectives of ACE is to measure and compare the composition of several samples of matter, including the solar corona, the solar wind, and other interplanetary particle populations, the local interstellar medium, which is ISM, and galactic matter. While there has been great progress addressing these objectives, the changing conditions over the solar cycle presents new opportunities. In addition, new observations and theoretical advances, new missions, and the evolving goals of NASA and the heliophysics theme have introduced new challenges, including the goal of achieving the scientific understanding and needed to forecast space weather in the coming years when humans will venture beyond Earth's protective magnetosphere. There are 9 scientific instruments on ACE. They are performing the following: comprehensive and coordinated composition determinations of elemental, isotopic, ionic charge state, observation spanning broad dynamic range, solar wind to galactic cosmic ray energies, recording the electric nucleon, hydrogen to zinc, solar active and solar quiet periods, investigations of the origin and evolution of solar and galactic matter, elemental and isotopic composition of matter, origin of the elements and subsequent evolutionary processing, formation of the solar corona and acceleration of the solar wind, and particle acceleration and transport in nature. Yeah, that's a list, isn't it? Okay. This is the satellite as it was being built right here in Colorado. So you can actually see the spacecraft. This is what the different instruments are on the spacecraft. Each one of these provide its own separate and unique data streams. This is the schematic drawing of the satellite. You can see exactly when we start talking about things like SWE, PAM, EPAM, SWIMS, all these different aspects of this craft. Here, you can actually see how the data is analyzed. Again, a more simplified drawing of how each one of these panels, exactly what they're doing, and how we take that data today and now understand, for instance, the solar wind stream. This is the making of the satellite itself. You can see the propulsion module. You can see the electron spectrometer, the magnetometer. What I enjoy about this is that when I see the data, I can now visualize and put that data to something that I know is out there. It's not subjective, it's not hypothetical, it's not theoretical. I know that there is, in fact, a spacecraft, a satellite that's out there, and this is what it's doing. This is some of how the data analyzing is going on. You can see how the isotopes composition, elemental composition, and going all the way down to the kinetic energy, which is MeV, the nucleon. That's basically, consider it like voltage, and it's not, but it's connected to that. ACE launched on a McDonnell Douglas Delta II 7920 launch vehicle on August 25th, 1997 from the Kennedy Space Center in Florida. The Earth is constantly bombarded with a stream of accelerated particles arriving not only from the sun, but also from interstellar and galactic sources. Study of these energetic particles contributes to our understandings of the formation and evolution of the solar system, as well as the astrophysical process involved. The Advanced Composition Explorer, a spacecraft, is carrying 6 high-resolution sensors and 3 monitoring instruments, samples low-energy particles of solar origin and high-energy galactic particles with a collecting power of 10 to 1,000 times greater than the past experiments. ACE orbits at an L1 liberation point, which is at a point of Earth-Sun gravitational equilibrium about 1.5 million kilometers from the Earth and 148.5 million kilometers from the Sun. From its location at L1, ACE has a prime view of the solar wind, the interplanetary magnetic field, and higher energy particles accelerated by the Sun, as well as particles accelerated in the heliosphere and the galactic regions beyond. ACE also provides near real-time 24/7 continuous coverage of solar wind parameters and the solar energetic particle intensities, space weather. When reporting space weather, ACE provides an advance warning about 1 hour of geomagnetic storms that can overload power grids, disrupt communications on Earth, and present hazards to the astronauts up on the ISS. The spacecraft has enough propellant on board to maintain an orbit at L1 until 2024. I just read they have now been able to consolidate through further processes that it's going to be up there to about 2043. This is the data. If you follow space weather, and those of us that do, this is where the data comes from. We understand the temperature, we understand the speed, the density, the phi angle, and the magnetic. So when we see in the phi angle, that's what's measuring the magnetic, what I call, you'll see the MIF. And this also goes to something that's going to be very important to us because we're going to see about the SWEPAM. This gives a visualization of where ACE Discover is sitting. 1 million miles out there. So that's where we get the 1 hour. So this is a diagram of all satellites that are in orbit, man-made. And you can see L1, you can see L2 is on the opposite side, away from the sun. L4, L5, SETI, and then we have SDO and others that are over here at L3. Gives another visualization of how satellites, when they're launched, what their orbits are going to be. ACE is in an elliptical orbit, And there are times when it's going to be at its apex, and there's going to be other times when it's at its apogee. Thought you would like to see this. This gives you an idea of all the satellites that we have out there, measuring, looking, experimenting, collecting data, learning. And we still have a lot to learn. Again, you can see the different satellites, where they are, their missions. SOHO, many of us use this one. Here is Chorus, Discover, etc. One more, good visualization. Our sun is big, very big. Our Earth is really small when compared to this. So now we're going to be studying what we call the solar wind electron, proton, and alpha monitor. That's nickname SWEPAM, SWEPAM. This measures the solar wind plasma, electron, and ion fluxes, rates of particle flow as functions of direction and energy. These data points provide detailed knowledge of the solar wind's condition and internal state every minute. SWEPAM also provides real-time solar wind observations, which are continuously telemetered to the ground for space weather purposes. Electron and ion measurements are made with separate sensors. The ion sensor measures particle energies between about 0.26 to 36 Kelvin, and the electron sensor energy range is between 1 and 1350 volts. That's with an E. It's a big one, guys. Both sensors use electrostatic analyzers with fan-shaped field of views. The electrostatic analyzers measure the energy per charge of each particle by bending their flight paths through the system. The fields of view are swept across all solar wind directions by the rotation of the spacecraft. Now, this is important because it gives us a really wide view, much bigger than that of the Earth. That's how we can understand, particularly when we see, we haven't seen them now because of the molar minimum of the sun, but when we do have sunspots that have the tendency to fire off flares, this is how we know. So I'm going to show you data now that's going to, well, I'm going to postulate to you a theory of mine that I believe I have captured the presence of something. And I'm going to use a number of different instruments off ACE. So here's my first set of evidence. This, to give you an idea, is our planet. The white here is the Earth facing the sun, and so this is the solar wind coming off the sun, hitting the Earth. This is where we have our satellites, and as you will see, this is also part of Earth's magnetopause. Okay? So it measures the magnetopause position. So you can see it where I showed you. The white semicircle is the computed location of the day side magnetopause. The rightmost position of the semicircle is 10 Earth radiuses upstream from the Earth, about 1 million miles. The most sunward boundary position is called the magnetopause standoff positions and includes their inner magnetopause of the Earth. So we actually have two. We have two defense systems. And there's 4 things to remember: plasma, density, temperature, speed. Okay? Now I'm going to go back to 2014 and go forward so you can begin to see with myself how I came about this. And you, of course, can draw your own conclusions. So here we go. Always look up here at the time stamp right up here, 6/1/2014. Here's the time code, 13/21/41 UT time. Now, this is our graph showing us temperature. This is plasma. All this around. When we see the reaction to this, it's an electrical universe. This is our defense system of the Earth's first initial defense system reacting to the sun's solar wind. All right? We have a number of satellites that orbit here. This is their orbit. So gives you the orientation of how we're looking at the data. The more it gets to the red, the hotter, the more to the blue, colder. Now watch. I'm just going to go through these and you can just begin to get orientated as well. Clear line right here. This is our magnetopause of the Earth, and we have another one right in here. Look in here, you can see here comes another wave coming in from the sun. Now, this gets interesting because you're probably already deducing to the fact, well, what happened over here? This is getting hotter behind the Earth. Well, kind of explain one theory on that is like in an airstream when you're trying to get coefficients in an aero package, let's say a race car, a plane. You want to have the slipstream as little resistance as you can. Well, our Earth will have a cavitation behind it at times. If it's a weak solar wind, well, there's nothing really here that would cause that. And so for this case, by the way, take a look at this. You can really see how everything is electric. So just some observations here, and we can go by here and take a look. This is warm, very warm. Now it's getting hotter. Now we're up here to, and by the way, I used the month of June on 3 data points for collection. June 1st, June 15th, and June 30th. And that way, and I just chose it randomly. I was born in June and said, well, why not? So I went back as far as I could get the data, 2014 to present. Now, June 1st, you can see really reacting to something here. There's something definitive that are magnetopause, and you can actually see the bow shock wave, how it will, if it's really intense, it will literally press into the Earth. And there we go. All right, so we're going now to 6/15/2014. And observe how you can really see the electric current that really is built here. And you understand how we're collecting the particles here and measuring this. Now look at this. Something is really perturbating our magnetopause, really interrupting it. 2015, 2016, 2017, now June. They only went back to the records of the 20th. There wasn't a 30th, so we're going June 28, 2014. June 30th, 2015. June 30th, 2016. June 30th, 2017. And you can see we're seeing patterns. We're beginning to understand that how the Earth is reacting to the solar wind coming in, and how the Earth is rebuffing these high charged particles and ion coming in. Now, something changed in June of 2018. Here's the evidence. Do you see something that's changed here, folks? Look at this. This shouldn't be this, but I'll continue. Are you seeing this? This is so far down on the graph, the scale, I don't know what to say, but something has changed. Either with our sun, it's not the satellite. Look at this. It reacts when we're hit by a coronal wind stream, the solar wind. You can see the Earth's magnetopause still reacting the way it would, but notice the difference of the plasma in the space. And this should not be black. And I've done it day by day here. You can go up there. This is June 8th. And I have no idea what the satellite, what the data is saying here, but that is just a strange effect. And look at what's coming from outside. This is coming from the outer solar system, the galactic center. Strong perturbations back here where the Earth is really reacting, and I'm not sure if it can't be the result. I have not seen one react like this. June 10th. And again, look at our graph. You saw 3.5 years of what it normally looked like. And then in June, something changed. Now, this should be what it looks like over here. What this is saying, what I'm interpreting that to be saying, something's hotter coming from the backside of Earth, which is something very different in the front side. It's like something has reversed. The 11th, the 12th, the 13th, 14th. Look at what's going on. The Earth is reacting. Remember, everything is electrical. So this satellite telemetry data is picking up the physical particles, the ions. It's not making this thing up. It's not like some of the models that are used out there that, well, they extrapolate. This is just giving us real-time data. The 15th of June, 2018. The 16th of June. And something here was really going on. Clearly, you can see we're still, the magnetopause is doing what it's supposed to do. And you can see, I put a couple of frames there together, and you can see now, this is clearly, you could see that this almost looks like electrical current. But again, it's this black space. It should not be that. It should be much hotter, folks. The 17th. The 20th. Look at this. And now it's like something has sucked the air, the heat out of the air itself, like a heat exchanger. And it's chaotic. This is the 21st, the 22nd. The auroras forming to the backside of the Earth, of our planet, is very interesting. And now strong electrical current hitting our magnetopause. The 25th, the 26th, look at this. It's closing in on itself. Now, we're going to do the Y cut. Now, the Y cut, so everyone can be orientated, remember what we're measuring here. We're measuring literally I always look at it as electrical currents. Every magnetic field has a closed loop. This is what's around the Earth. This is what we would call our inner magnetopause. The polar cap here is that you have a north going out, you have a south going out. These typically will connect with other planets, connects with our sun. Then you have what we call the IMF. This is the, I call it the intermagnetic field lines that are generated by our sun and the Milky Way, the universe itself. And you can see how when it comes in here, it reacts to the Earth. I mean, imagine that you have, I don't know if you've ever seen a helicopter when it comes through smoke and the wake that it produces. And it produces many times a wake, a vortex effect. And so the inner magnetic field lines will react to the Earth's magnetic field lines. It also will react to something other than the Earth or the sun. All right? And again, background plasma right here. So this is coming off of the sun. Now we're at June 1st, 2014. Let's walk through this. You can watch the time code. June 15, 2014. Look at what's going on here. Our closed magnetic loop lines, which should be around the Earth, you can see how here they do exactly what they're supposed to do in protecting the Earth. Forms this shield right in front of us. There is a corresponding tail that goes through, because remember, we are moving through space, and every action has a reaction. But it's extending way out, and you can actually see this is kind of like a normal flow out of our magnetic lines connecting to the solar system. But just watch this. June 1st, 2016. Something is throwing out our magnetic field lines. June 1st, 2016. June 1st, 2016. Look at this. The instruments are recording something that has just, well, this is literally, you can see where it's coming off of the Earth at and how it's getting looped into here. There's something of a density center right here. June 1st, 2016, more of it. And you can see the effect. As it gives us real-time data, you can see how I'm collecting the data, particularly right up here on the time code stamp. Now that was 4 minutes. And look at what's happening here. These IMF lines, something is behind here is what I'm trying to say to you. And you can see the billowing of the Earth's magnetic field output lines. And I'll continue to let it go out. You can see like it passes us by. Now, 2017, June 1st. Strong solar wind could be a coronal hole, but you can see it. You can see how the IMF lines, again, they're going, it's like going on a boat on a lake. You know, you're going to see your wake going behind you. This is more normal to me. But again, watch what happens. This is June 1st, 2018, when things begin to change. Now, I want you to pay attention to this plasma density field right here, because something is going on here. Now, look at here. This is 2016, the infamous year. Here's 2014. This is June 15th, 2015. Yeah, we've seen this before, haven't we? June 15th, 2017. Something has completely disrupted the Earth's circuit here. Completely. June 15th, 2018. Now, I want you to notice the intensity of what the instrumentation is telling us, that this is extremely warm. But look at what's happening here. You can see that the Earth is encountering something that would be the equivalency of a strong, let's say, the impact of a coronal hole, potentially a CME. But what I've noticed now, and others have noticed, is that we're starting to find these anomalies. And they're always with the Earth. I'm going to get into this a little bit more. This is June 15, 2015. Look at what was right behind the Earth. Now, what I have tried to do is to see if I could connect the Earth's own magnetic output lines, and I can't seem to locate one. Obviously, you can see that this is spherical. Again, look how it begins to react. June 15, 2017. June 15, 2018. Again, look what's going on right here. And strong IMF lines. Our sun right now is asleep. June 15th, 2015. Again, this odd anomaly. It returns much more often than I had thought. And it would do exactly like you would think something magnetic or electric would do. The Earth would react to it. And it's clearly a sphere. Look at that. This is just bizarre. It shouldn't be doing that at all. And again, the density field. And you can see over the years how we have the reoccurrence of these. And again, now we're going to get into what's happening to our planet. Here is, I'm going to go June 16th, 2018. Notice, again, this is what I would expect a closed loop to do. Looks like a spider, doesn't it? But look how the magnetic north and south connecting lines doing out. And again, we have this weird anomaly out here. Here it is again. Here it is again on the 18th. Very well defined. Look how the Earth now is in some sort of, it almost looks to me like a perfect slipstream. Now on the 19th, lowest solar wind speed recorded. Makes one wonder what are we reacting to here? Here's the 20th. Again, these anomalies now, these dark spheres. Are they stellar cores? I'm not sure. But I do know that they're here and they're being recorded by the instrumentation of ACE. And they do not dissipate. And look what shows up here again. What are these? I don't know. But I've tracked them. I'm recording them. And I haven't even gone near through the amount of data that's available. But you can clearly see how our magnetic field is reacting to whatever this is. And you've seen the evidence I've presented to you. 2 different instruments, and something is out there. And watch how it departs. And look at it again. You can see for yourself the 24th. And there it goes. And it slips out, and the Earth goes back to what I call a little bit. Look how the lines are avoiding the area out here. And here is the anomaly again. Here it shows up, a perfectly dark spherical object being recorded. Here's the 25th of June, 2018. The 26th, look at this. And then we get back into a normal pattern. But these spheres are here. And here was today's. Now, I went to the Z-cut. This measures the intensity of the solar wind itself. Density, plasma, temperature. Now, normally you would see coming right off of the sun, this is where the solar wind would come. And again, I talked about having a cavitation behind our planet, which is normal to a degree, but it should recover very quickly. So let's go and see what this one shows. Again, I'm doing the same 3 dates. June 1st, 15th, and 30th were allowed. Closest enough. Now look at this. Strong, strong solar wind coming off. Intense heat. It's hot. Earth's magnetopause is reacting directly as it should. And you can see there seems to be a cavitation here, but it recovers very quickly. And this is moving very fast. I mean, 400,000 or 400,000 kilometers per second. That's hauling. Now, here is June 1st, 2015. June 1st, 2016, June 1st, 2017. Strong solar wind, instruments are picking up, and exactly like it should. This is how it should look. This is about as normal as you could want to see it. But look what happens here, June 1st, 2018. We have the same effect of those spheres that we saw over on the Y-cut. June 15th, 2017. Look what's happened back here. It's like there's something heating up back there. And again, look at here. June 15th, 2018. Here is that sphere that we saw on a different complete instrumentation panel that would not pick it up. They don't measure the same thing. But there it is. This is today. Here they are. And look how it's impacting the solar wind behind us. It's almost like it's pulling into rotation. Now I go back to June 30th, 2015. June 30th, 2016. June 30th, 2017. Now, I said, okay, could I find a correlation? Again, using a separate camera, separate instrumentation panel, excuse me. Easier for me to say, huh? So I went to core. So I went here to June 1st. Now I found this little odd anomaly. It's only there for a little bit. And I went and looked at the data and I said, okay, are we seeing anything? Well, actually we do. And you can see the dates. There seems to be, in more cases than not, a correlation directly to our sun, which we've picked up. Now, I went to LASCO 3. I said, okay, are we seeing other anomalies that could very well have an impact? Well, you can look down at the dates. Here's June 15th, 2014. Here's the 30th. Here's June 1st, 2015. And you'll begin to notice we live in a very busy solar system. There are planets, there are things around here that most people have no idea exist, and they come in from every different direction. Are we seeing a possible correlation? Well, I went through the data, and this is Venus, by the way. I think yes. Have no idea what this is. And as I began to look at this through the years, there were always anomalies. Correlating? I don't know. But you have to look at all the data. Again, always coming in, as you can see, here is June 30th, 2017. Here's June 1st, 2018, June 15th, 2018, and then today. Look at this bad boy. A couple of them, actually. Okay, I said, well, there could be potentially a correlation. So then I wanted to go to the last one, which measures the sun magnetic bands. And this instrument here measures, there is a field around the sun. It's called the Helmut streamer belt. It's a packly, dense pack of ions and particles. And it moves with the sun. It's as the sun's corona moves, etc. The purple lines are the coronal holes. And of course, you have the intermagnetic field lines, right? So, and the sun, just like the earth, has a closed magnetic field line. So I'm looking up here and I'm going, okay, the first one I have is for June 1st, 2015. The 15th on the 215. The 30th, 2015. And you can see here's the sun. You can see how the density of this belt, the streamer belt, goes around. You can see here how the coronal holes are coming out and their associated electromagnetic impact. Here is the only one that they had on this one was May 31st, 2016. You can see the bands. Very interesting how our sun works. Here is June 15th, 2016. And you can see there's a consistency in over the years of how the band, the belt works, and the coronal holes. We can see all of this, and you can go back and measure it. Here's June 30th, 2016. 2017, something begins to change. And you can see it. It's flipped as though that there is something going on, but it's becoming more compressed. There's the 30th, 2017, last year. This is June 1st, 2018, this year. Look at this, folks. This is not good. We see that. When you have that type of, where it's directional without any kind of diffusion, and look at the suppression of the Helmut streamer belt. Look on the 15th. We've been saying Claudia and I in our Monday night shows, something drastically is changing with our son. This is dramatic. In fact, I hadn't even expected it to come in. So there you go. That is my case for you. I hope you've learned a few things. And what do you think of my evidence? Give me your comments. If you've stayed this long, this tells me you're like where I'm at. You really want to know, because when things are going to hit the newspaper, in the internet, on other channels, you're going to have knowledge that you can go and say, I can verify that, or I can deny that. So, hope it's been fun. We'll talk soon.